In lesson 2.1, we talked about inductive reasoning, but in 2.2, we're going to talk about deductive reasoning. Now, deductive reasoning is a little bit different. It's oftentimes one of the things that we use in mathematics, as opposed to inductive, which is much more used in observational studies, which is much more scientific method. So deductive reasoning is the process of showing that certain statements follow logically from agreed upon assumptions. And so that's why this is more used in math more than anything else. And then once you do that, you know that there are certain things you agreed on, like point, line, plane, and proven facts. And then from there, you use some kind of orderly manner to convince somebody that your hypothesis or conjecture is true. An example occurs when we do algebra, and then you provide the rationale for each step. So down below, what you'll see is that we have an equation, which is our original equation. And what we're going to do is we're going to solve this equation, and we use mathematical agreed upon processes, and that's why this is deductive reasoning rather than inductive. So step one when we solve this is we try to combine some like terms. So I notice that the 3 times the parentheses on the left side and the 2 times the parentheses gives me the 5 times the parentheses. And then nothing else combines for like terms, but this is called combining like terms. And that's something in math that we should know how to do from algebra. And then after that step, I notice that I have the 7 on the left-hand side that I don't really want that there, so I subtract 7 from both sides. And we call that, of course, the subtraction property. And then after subtracting, I don't really like the fact that there is a parentheses on the left, so I multiply the 5 that's on the outside of that parentheses by each term on the inside. And when I multiply that, I'm using something called the distributive property, which again is another mathematical processes that we agreed on how it works. After I do that, I notice that that I see that I have on the left-hand side a 5, and I want to subtract 5 from both sides. So I subtract the 5 from both sides, and you'll notice that there's an error in this equation. This came out of our book, but this number over here, the 32, is actually supposed to be a 35. So you're going to have to kind of ignore that for a second. I apologize, but that was from the book. And so I have 10x equals 30 minus 5x. Why did that happen? It's because I subtracted 5 from both sides of that equation. And then what I notice is that that 5x, which is negative on the right-hand side, should go with the x term on the left-hand side. So I add 5x to both sides of my equation. That's called the addition property. And then finally, when I get done, what I see is that I should divide both sides by 15, and that's called the division property. Again, the really important thing in this slide is not the answer x equals 2, but the process that I used as I went through from top to bottom, in that every single step that I was using to find my answer or draw my conclusion was using steps or an algorithm of agreed upon methodology in mathematics, so that is called deductive reasoning, because they're logical steps that follow based on things I know are already given to be true. In our second slide, rather than using equations to talk about, we're going to use figures. So take a look and you see a set of angles here. And the first statement says that ray AC is bisecting each obtuse angle ABC. So I know that AC is bisecting that, and in this case, actually, this is incorrect. It says AC, but really what it should have said is ray BD. So my apologies again. This should be ray BD, not AC. And so as I look at that, what I see is here's a ray that's bisecting in every single case. That's being told to us. We then can classify each angle ABD and DBC as acute angles, because I know that if these are all obtuse angles, I know that they're all more than 90 degrees but less than 180. So I know that each of the remaining angles have to be acute. So it doesn't even matter what the original size was. For example, if I know that the original size of angle ABC was 160 degrees, and then I bisect that, I see that left over I have 80 and 80, because the word bisect means that I chopped in half. Or I could have told you that that angle ABC was 140 degrees. Again, if I bisect it, it means 70 and 70. And then in the last one, if I wanted to say, for example, that that obtuse angle, whoops, bad color, maybe I should choose a different color, sorry. That angle was maybe 120 degrees, which is also obtuse. Then if I bisect, I get 60 and 60. And what you'll notice in every single one of these cases is that the resulting angles, which are equal to each other, are all acute angles, meaning that they're all less than 90. And so that is also deductive reasoning. And then lastly, kind of a combo between pictures and numbers here, we have some segments. So I know that in this picture, I'm being told that segment AB is congruent to CD, and you see the markings. So if I put that down there, what I know is this AB equals this CD, and this AB equals this CD. That's given information. From that information, if I knew that segment AC, which in this case, in the top figure right here, is 100, and I also know that BD is 100, then I know that AC and BD from what we know then is that the AC and the BD are both 100, or in other words, are equal to each other in that first figure. Likewise, in the second figure, if we know that the AB and the CD are the same, then from A to C, I know would be 116, and I also know that from B to D is 116, and they're equal to each other. And what this is trying to show is, even if I did not have numbers associated, so for example, if I drew another figure that had the same exact letters on it, so here's A, and here's B, and here's C, and here's D, and I tell you that I know that AB is the same size as CD, and that's all I know, and I write that off to the side. AB is congruent to CD. Then what I can deduce is no matter how big the BC is in the middle, it doesn't matter. I will always know that the length from A to C will always be congruent to length from B to D. And I don't need any numbers to tell me that once I know those two small pieces are congruent, AB and CD in the orange. That also is called deductive reasoning. So the first two examples up top are showing how it works with numbers, and down below the whole point is I didn't even really need the numbers to know that AC and BD are going to be congruent, because I know that no matter what BC is, I'm adding it to those two equal pieces, and so the result will also be equal. Or in this case, of course, we would use the word congruent.